Here we go. I'll try that again, Karis. Sorry, I had the wrong thing. Right, off you go.
So are we on the second slide? I don't know if there's a delay there.
Is it working now, Karis? It should
I was
be.
going to do a little section about me, but so there's just a picture of me there on the right. Pick up anything I said tonight. Yes, can you hear me?
Yes, we can.
I think I'm having some delay. Can you hear me now?
Yes, perfectly well.
I'm just going to switch back to my laptop. Sorry.
Okay, no worries.
Sound okay now?
Yes, you're good.
All right, great. I wasn't sure if it did echo because of two devices. I think I was having some delay on the phone, so I'll try my laptop for now. I might have to switch, so bear with me.
Okay, no worries.
Apologies. Okay, so yeah, that's me. If anybody's got any questions after the presentation, there will be a chance to ask some questions, but feel free to get in touch with me on any of those details as well. So if we go to the next slide, please. So tonight, I'm not sure who my audience was going to be, so we've done a little bit of history on gauging. I think it's always good to understand the background, so bear with me if you're a gauging expert. We'll get to the good stuff later. I'll then go through the current technology, explaining where we are today with technology and techniques. I'll then discuss some of the challenges that we have in the gauging world, and we'll have a look at the future of gauging, or I guess my opinion on the future of gauging through my experience. So for anybody who's not heard of gauging before, I'll start by answering the question that you might be wondering, and that is what is gauging? So if you skip to, next slide, thanks Louise. As it says there, it's the management of clearances between vehicles and line-side infrastructure or adjacent tracks. So within the rail industry, we need to make sure that the vehicles don't come into contact with the infrastructure or with passing vehicles. And where there is a passenger train interface, we need to make sure that people can get on and off the trains quickly and most importantly, safely. I'm not sure, there should be some images there. Can you not see the images?
Yeah, we've got a passenger trying to step onto.
Okay, yeah, no, that's fine. It must be my Wi-Fi, so that's fine. Okay, next slide, please. So the history of gauging. Like I said, we're going to step back in time and just have a look at why we have to consider gauging and kind of where all the troubles began. So if you go on to the next slide, please, Louise.
Mm-hmm.
So why do we need to consider gauging? Within the UK, the railway as we know it today originally started life as lots of localised routes. They were all built and operated by small private companies. And then during the 20th century, many of these routes were amalgamated and bought out by competitors. So eventually, patchwork of railways were all kind of linked and operated by four main operators. And then in 1948, it formed one kind of British Rail. At the time, we had different track gauges. So we had Brunel's broad gauge, which was popular on the Great Western Railway. Then we had George Stephenson's gauge, which became the standard track gauge that we use in the UK and in many countries around the world. So although we've managed to standardise the actual track gauge itself and modernise the railway, we're still having trouble kind of standardising the gauge compatibility across the network, and it's an ongoing process. There's just a legacy of all the different railway builders and vehicle sizes, and we're still seeing the restrictions of the operation on vehicles and freight gauges on certain routes. I'm often asked why we can't just rebuild structures to fit all of the vehicles, or why we can't replace rolling stock with small new vehicles, small enough to operate everywhere. Not muted.
Shall we?
Sorry, I've lost my train of
Carry
thought.
on, Karis. Sorry. I'm going to
Yeah.
mute.
Why don't we rebuild the structures or replace the rolling stock? And I think that the main answer that I give is that it's just expensive to rebuild the infrastructure, but also there's not a lot of room to expand the railway anymore. We've built on a lot of the railway corridor boundaries. There's a lot of houses gone up and factories. We also have a lot of listed structures on our network, so we're just not allowed to alter them. And also the train operators wouldn't be very happy if we asked them to get rid of their legacy rolling stock and replace it with new. There's still plenty of life in the vehicles that we've got operating on the network. We did look at creating a go anywhere gauge, so we had a look at how small would we need to make a vehicle for it to fit anywhere on the UK rail infrastructure, and it ended up leaving very little space to be a viable option. So instead, we're looking at ways to improve gauging techniques and make the technology more accurate so that we can use as much of the space that we have already available, and ideally reduce the need for any expensive modifications of the existing infrastructure too. So just the next slide then, please, Louise. So if we look back in history at how we managed the gauge clearance in the past, especially after merging so many different rail operators together, luckily they did kind of design with consideration to gauging. So there was a gap between the train and the infrastructure. This was designed to account for movement of the vehicle, mostly due to centre and end throw of the vehicle. So if you think you've got a long straight vehicle operating on curved tracks, it throws kind of and sticks out on curved track. Back then the vehicles had stiff suspensions that didn't bounce around as much as the vehicles that we have today, and they operated at lower speeds, so we didn't have to take much else into consideration when thinking about this gap that we had to leave. To manage the gauge clearances then, we had static drawings of the vehicles and infrastructure. So these are kind of scaled drawings done by draftsmen in an office to they draw out the vehicles and draw out the structures and physically measure the gap between them to make sure that the gauge clearance was sufficient. The equipment that we had as well was quite simple. We had pull and tape, which is the diagram on the left there. We would have to measure from the rails and measure up and around the structure. We'd have to make sure that we picked enough points to actually capture the features of the structure. So on this example, there's an arch there. If we capture too fewer points, we risk kind of making a 50p piece out of the survey. So these surveys took quite a long time to carry out. We then, at platforms, we had these platform gauges to measure. I like to refer to them as a giant engineer set square. They'd be used to measure the height and the offset of the platform to the nearest running rails. We do still use very similar platform gauges today, and then the data that comes from those measurements we use to calculate clearances and stepping distances for passengers. And then another technique that we would use to check gauging is the loading gauges that you see on the right hand side of the picture. These gauges we use to check the maximum height and width of vehicles to make sure that their loads could safely pass down the infrastructure. And again, we still use loading gauges today, but they're a little bit more complex than the diagram that you see. So I'll come on to that next. If we go on to the next slide, please. So this section is now about the current technology, and if we skip to the next slide. Thank you. So as I've just mentioned, we do still use loading gauges in the UK and generally around the world. But the loading gauges that we saw in the previous slide have evolved. We've got a set of loading gauges that we use as standard. These are listed in the table on the right. Each of the coordinates of the vehicle, the gauges would then be adjusted according to movements induced by cant and radius and speed. So for vehicles and vehicle loaded combinations to be declared as conforming to standard vehicle gauges, the vehicle itself must fit within these specified parameters. So to put the diagram on the left, it is slightly outdated in comparison to the table, but it just kind of gives you an idea of what some of our common gauges look like and how they all kind of sit within each other, a little bit like a Russian doll effect. So we do have the risk benefit of using the loading gauges, and that is that we can easily define and maintain a route and a route capability. We can identify which vehicle and load combinations are permitted to operate on these routes as well. It makes it really easy for the freight operators. They're a huge fan of gauges. It's something easy and kind of free to understand. But there are some kind of issues with the loading gauges. We've got a common misconception that building the vehicles to the smallest gauge will allow the vehicle to access kind of all of Network Rail's infrastructure. But we currently have around 11,000 substandard clearances to W6A, which is our smallest freight gauge. And obviously there's more restrictions to the bigger gauges as they grow. We can break these substandard clearances down into a few different categories. So we have inherently tight infrastructure. So that's kind of stuff that was built just too small for modern gauges. And we didn't have any gauging controls in place when the networks were all brought together and gauge capability was merged. So these legacy locations are sometimes restricted to the loading gauges. We've then got locations which have not been maintained to gauge. So since
Sorry, Karis, I think we've lost you for a moment.
Sorry, I think I went, didn't I?
You got to just after the legacy assets. You were talking about assets which haven't been maintained.
Yeah, I've had to just switch back to my phone. I'm so sorry.
No worries.
Hopefully you can hear me now.
Yes, we can.
So yes, the locations that have not been maintained to the gauge, this is when something's happened. Since the gauge was approved for use on a route, the structures have either moved or moved on purpose, either or kind of just moved by kind of movement of traffic. So yeah, there's inherently tight infrastructure, and then locations that are not maintained. We've also got some locations with data quality issues, so with the difficult to capture because maybe vegetation. We also have had missing data as well. So if we go back to 2009, so 12 years ago, we had 142,000 structures in the National Gauging Database, which is the kind of database that we store the structure data in. I just checked the figures today and had a look at how much we currently have in, and we've got 125% more structure data in the National Gauging Database than we did back then. So again, I think some of the substandard clearances we just didn't know about at the time when the vehicles were introduced onto the networks. So we've got like a huge kind of legacy of these tight clearances. On top of that, we also know that the loading gauges have a lot of unused space within them. So when we consider individual vehicles, they're not necessarily using the full amount of space in those gauges. It could be, we tend to get a lot of container traffic in the UK. So if you picture a container box on kind of the top of that red line in the left gauge, you can see that the kind of the top corners are not being used as much. You can see where we get the taller containers coming out of the top there, but we might, there's all sorts of different sizes of container traffic. And yeah, I think we're kind of just categorizing them as the one that they fit in, whether there's extra room or not. So there is kind of ways that we can unlock that unused space. We don't use it so much with freight trains, but more so on passenger traffic. We use a method called absolute gauging. So if we go to the next slide. Okay, so we've been using computers to calculate clearances for about 40 years now. And the earlier calculations were just a replica of what the draftsman would do on paper, and that was just model the static vehicles and the structure gauges. But as we've become ever more advanced, we've taken into consideration dynamic behaviours of the vehicle on its suspension and understand how it affects the clearances. The assessments consider how local speed, installed cant, curvature and track quality affect the vehicle in relation to accurately measured structures. So by breaking down the vehicle into more detailed slices, we've been able to accurately model the behaviour and have a lot more confidence in the calculations that we're doing to understand the gauge clearance. So we've gone from those kind of earlier gauge clearances needing about 150 to 300 millimetres of clearance to now, I mean, so I've seen some vehicles operating with as little as kind of 1 millimetre of clearance, because we're so confident in the measurements that we've done that we've covered everything. So it's great. We've kind of unlocked a lot more potential with absolute gauging. The vehicle model itself is not the only thing as well that we've got more confidence in. We've also started picking up a lot more data. So I touched on the amount of data that we've now got in the National Gauging Database, capturing in that. So previously, when we've done the poll and tape surveys, we've maybe just captured one slice of a structure or a few slices of the structure, and those slices are isolated just at the point of measurement. With the structure gauging train, we can continuously measure a structure, so we're capturing the whole thing, and then we're breaking it down into usually 5 metre slices, but we're squashing all of that data from the 5 metres into one composite file. So we're making sure that we've captured the tightest points between the structure and the track. So yeah, the two together, the vehicle modelling and the gauging data that we now have, is just, it's a lot more accurate and gives us a lot more confidence in kind of getting modelling the vehicles closer to the infrastructure. If we go to the next slide, there is an additional benefit on kind of absolute gauging, and that's that we can reverse engineer the decisions that we make. So if we're looking at introducing a new vehicle on a network, we can have a look at the infrastructure that might be an issue to that vehicle and have a look at pulling back some of the designs on the vehicles. That we've worked with clients before, where we've had a look at the best position for a footstep on a vehicle, and kind of analysed it against the structures to see which footstep gave the best clearances, but also the best stepping at platforms. So the image that you're seeing on screen at the minute is our gauge builder. We apply the dynamics to the structure instead of the vehicle to see the amount of space that we've got left. We can then chip away, and anything that's going to be unrealistic or that we want to go out and actually modify. So for instance, if there's a ground signal in the way, that they're pretty cheap to move. So it might be that we ignore that and we don't try to design our vehicle around it. But there's lots of kind of stuff that we can do there in terms of absolute gauging and the reverse engineering. We can have a look at like the cost analysis of modifying the vehicle versus modifying the infrastructure. So yeah, I think that kind of covers that point. So the next slide, please. We'll have a look at the challenges that we face today, and I guess why we've still got, although we've got absolute gauging and the loading gauges, we still have trouble and we still need to progress in the gauging world. If we go on to the next slide, please. Okay, the first thing to point out is that the railway needs to be maintained. So again, clearances sometimes need to be used up to improve track quality. For instance, during the life of the track, the ballast usually lasts around 30 years, but in that time it could be tamped kind of 4 or 5 times, and we need to leave some room for the track to be lifted or slewed towards the structure. So we start off with, at renewals, we install normal clearances. And then we obviously, like I say, we make allowances for the track lift and slews. As these clearances then reduce, we increase the controls and the check-in at the structure. So we do extra clearance checks. So not only do we measure with the structure gauging train every 4 years, we would then go out and manually monitor the structures. They have datum plates on them, which is just a point that we can measure and track the position of the track in relation to the structure. So that then feeds back into whether there's been any movement at the structure and whether any intervention needs to happen. So to make sure that this life cycle works, there are procedures in place to manage the tight clearances. And if we go on to the next slide, please. So I'm going to speak for Network Rail because that's the standards that I know really well. In 2008, they brought in some new standards which were introduced for monitoring and maintaining tight clearances. At that point, we didn't know what was legacy infrastructure, as in what had been built too tight at the time. And we had to draw a line somewhere. So in 2008, we kind of said anything that was kind of foul or special reduced clearances were categorized as legacy structures. And then anything that became a tight clearance to the vehicles after that, they had to be resolved within a set time frame. So for example, if a track was moved towards structure and the route cleared stock became foul, this should have been resolved immediately. But in my experience, it's not always been happening. And I think that's because there's nothing to enforce it. There's no kind of key performance indicators around gauging. And to be honest, we're not really ready for that in the gauging world just yet. If we all of a sudden went out and said that everything needed to be fixed and restored back to normal clearances, we'd open a big can of worms. I looked at the figures, and we've got around 5% of our overall infrastructure on the network, on Network Rail's infrastructure, is substandard to the route cleared stock. I tried to have a look at how much of that substandard infrastructure actually causes a reportable incident, so where a train strikes a structure or another train. I couldn't find anything. So again, speaking from experience, I'd say it's probably less than 1% of the substandard locations, like per year, actually have an incident. So that kind of raises the question of how we're doing the calculations and the tolerances that we use in the calculations. There's a perceived conservatism within the gauging world. And from experience, again, it's not until a structure is about 50 millimeters foul that we actually see an incident occurring. And what we're doing is we're stacking the tolerances on top of each other and then calculating the clearances based on the very worst case scenario. So there has been some research into using probabilistic gauging. Some of you might have heard of that being thrown around. It's a statistical analysis using Monte Carlo. We review the amount of tolerances that we apply to gauge clearance calculations, and then based on the probability of the tolerances happening at the same time, we use a risk-based approach to manage the tight clearances. So instead of Network Rail having to go out and fix all of their tight infrastructure straight away, we can then move to a more manageable approach. Another challenge is the actual measurement and the processing of the data. So I mentioned that the capturing of the data has grown significantly, especially over the last 20 years, with all the train-borne systems that we've got out there now. We're capturing loads of data, but we do have a kind of an issue with processing that amount of data, and we're just struggling to keep on top of the processing. So we're not making kind of full use of these surveys. There's a lot of opportunity there to kind of remove people from the track as well. So the people that are going out to measure the structures in between the structure gauging train, that they shouldn't really be doing that, because we're probably capturing enough data that means that they don't have to. Then another challenge that we have is they're quite blinkered in the gauging world. We're very hot on being concerned about structures, so bridges, platforms, tunnels, ground signals, signs, and we measure them a lot and measure the clearances to them. But what we don't do very often is measure the passing clearances between two vehicles. And we do have plenty of data there, we're just not using it. And then the kind of another kind of big issue that we have is that the gauging software currently doesn't account for vehicle movement on transitions, particularly through S&C, which is our biggest risk, especially for longer vehicles. So we recently introduced the IEP, which is a 26-metre vehicle. It's the longest one that we've ever operated in the UK. So we had to do a lot of extra work to make sure that we were comfortable how that vehicle behaved through S&C and transitions. But ideally, we should be looking at everything to make sure that everything's safe. So that's probably a lot of things to take on board then, in terms of what we're challenged with in the railway. I guess I'll summarise in that we've got a lot of legacy tight infrastructure, so it's costly to fix. We're not managing the tight clearances in the most efficient way. We need to be using a lot more of the data that we collect, and we need to be considering the whole railway system and not just these 2D slices that we're processing. So with that in mind, let's have a look at the future. So if you skip to the next slide, please. And then I think just one more. Thank you. Okay, so a lot of this is just kind of based on my experience and my thoughts, but hopefully I'll give you some insight into how we need to move forward in the gauging industry to make some improvements. First of all, we need to have a look at the vehicle models and the loading gauges. If we can move everything onto dynamic gauges, we'd have a lot more reliability on clearances. We'd be able to use a lot more of the space. We obviously have the issue, we have to balance that then with the freight industry doesn't want to break down the container on wagon loads. They want to operate gauges and kind of keep it simple, so that they can plan their routes. We've then got, we need to start moving the use of manual measurements. They're not as accurate as the kind of the train-borne laser equipment. They're also not as safe. We're putting people out on track when they don't need to be. So I think it's really key that we remove people from the track. We've then got to automate the monitoring of movement at tight locations. So not only do we take the people away from measuring that, we need to start tracking and trending the data more. We have done some of this in the past, but I think there's a lot more opportunity there to kind of flag up any risks of infringement. If we're tracking all of the data. We've then got the obviously the risk assessments and probabilistic gauging side of things. I think that's going to help quite a lot in terms of managing the tight infrastructure. It'll help deal with kind of challenges in understanding the gauge capability of routes and how we can improve the gauge capability of routes. So I think it will feed into like a decision tool somehow on increasing route capability based on risk. I then think we also need to have a look at the civil ones. We started using a lot of point cloud technology recently, so this is very accurate data. We can use it not only for gauging but for things like track design. So we could be looking at design tamping. We can use it to have a look at other disciplines, like the interface between other disciplines, to see how changing something to improve gauging would change something to, say, the overhead line clearances. The point cloud data is also really key to kind of improving the passenger train interface. So because we can kind of look at the full train, the full survey, we've got a much better view of kind of blind spots at train stations. We can have a look at stopping distances of the vehicle to make sure that we're stopping in the best position on the platform to make stepping and access to the train much easier for people. So I think kind of some of these things I've touched on, and we have already kind of trialed these on other networks, and they're really changing the way people approach gauging. And I think if we can then take this approach to the network rail infrastructure, we've got a lot more opportunity to kind of improve safety, improve gauge capability. I'm just trying to think. And then if you go to the last slide, I think it is now. So just as an example of the point cloud data that I talked about, we've got here, so the larger image is that's laser measured data, which looks very similar to the photograph underneath. But we can measure that laser data within plus or minus 5 millimeters of accuracy. So when you compare that to the surveys that we were measuring kind of 50, 60 years ago, on the right there, you can see that we have come a long way with technology, and that's only going to grow with the more data that we use. So I think that's everything from me. I think there's just, I think was there time for some questions?
Thank you, Karis. Yes, there is definitely time for questions. I'm just going to bring this off screen. And then invite people to turn their cameras on as they wish. If you'd like to ask a question, for the moment, these questions are formal, and I have to say under GDPR, if you don't wish to be identified under GDPR, I'm afraid you just need to refrain from asking your question. If you're comfortable with GDPR, then please do raise your hand or drop something in the chat box, depending upon how you're able to communicate. So please feel free to turn your cameras back on now. Now we're not having the slides coming through. That's not so much of an effect on bandwidth. This is your opportunity to ask Karis to explain on something you perhaps didn't understand, or if you'd like to make a particular point or raise a particular case study, that's perfectly appropriate as well. So this is your forum. Please take the chance to make best use of it. So I suggest, if you'd like to ask a question, either turn your camera on and wave your hand at me, or you can use the buttons at the bottom of the screen to raise your hand and indicate that you'd like to say something. Right, Andy's waving his hand. Do you want to go first, Andy?
Yes, please. So thank you, Karis, for a very informative presentation. You mentioned W6 in your slides, which is a common gauge for on-track machines and obviously wagons. 11,000 exceedances to this gauge. What is Network Rail and its industry partners, such as yourself, doing to reduce this number and make the railway more accessible to everybody?
Okay, so there's a few answers to that. I think it depends on the reason for the substandard clearances. So if we go back to, I think I mentioned that we've got the inherently tight infrastructure. So that's the things that we need to spend a lot of money on fixing. Those ones are mostly kind of down to looking at the route strategy. Does that route need to be capable to kind of permit that gauge down the route? If the answer is yes, then I think it needs to be budgeted into route enhancements and upgrades. But then I think it also, that's one of the reasons that we're looking at the probabilistic is it actually as tight as we think it is, or can we have a look at what the tolerances are doing at these locations? Do we think that there is a high risk of something hitting that vehicle? We've then got the locations that have not been maintained to the structure gauge, sorry, to the vehicle gauge. So for instance, W6A. There's routes where W6A are operating on where there's locations that haven't been maintained and they're technically foul. So we're just the kind of, there's a bit of a comparative assessment going on there that these legacy vehicles have been operating for a lot of years without any incident. So that it's just a case of, again, I think risk assessing that as to whether it's going to get any worse than it is currently. The locations that have not been maintained are generally quite easy to fix as well. So I think some of that will come back in the maintenance standards, that they'll need to go out and fix those locations. We've then got data quality issues that are causing some of the standard substandard clearances. So again, we're working quite closely with Network Rail just at the minute, actually, to try and improve the data quality of the data and just iron out everything. There's always going to be something that slips the net, but I'm hoping that there'll be much less data quality issues in the next kind of few months.
Do you class vegetation as data quality issues, or is that a separate category?
Yeah, so vegetation is probably one of our biggest kind of data quality issues, and there's not, unless the structure's been remeasured since, there's not always a lot that we can do about vegetation. It just depends on the time of year that we're running the vehicle past there. So there's maybe some work to be done there to say on certain locations that we know are really bad for vegetation, get a survey done in the winter. But sometimes I've seen it myself that we're getting new data in and it's even more vegetation because it's growing even bigger. So yeah, vegetation's difficult, but hopefully our new vegetation frame will solve some of that problem. I think, did that answer your question?
It did. Thank you, Karis. Yes, a very, very, very good answer. Thank you.
Jolly good. All right, Luke, you've put in a good question. Would you like to come on the screen and ask for yourself, or would you like me to ask it? Okay, where's Luke? Okay, fine. So Luke's just come back. He said he's in a loud environment, so I'll ask it for him. So Luke has asked, what is the rolling stock and infrastructure should look towards to become fully harmonized? I think this might be a question that could be as long as a piece of string, Karis, but have a go.
But I think we need to take a bit of a holistic approach with it. And I think we are doing currently is that we're upgrading certain routes depending on what that route needs. So we've got, we're constantly upgrading routes with W12 capability, but there's always going to be the odd little branch lines that don't get many vehicles operating down there that are probably never going to need to be cleared for the biggest, fastest vehicles. But I think it's just a case of having a look at the strategy of those routes and the needs for them, but also then I think getting smarter with the technology so that we've got, I've said it several times tonight, but more confidence in the data so that we're happy that we can operate the vehicles that are working on those routes.
I think that's probably a good answer, Karis. I'm afraid there isn't really a simple answer, even though it's just a question.
I think we are, just to add to that, actually, we are looking at kind of standardising some of the passenger gauges as well. So we're looking at standardising the freight gauges, but then we've also got some new passenger gauges that we're looking to try and standardise new vehicles too. So at some point, all of the legacy infrastructure, all of the legacy vehicles will be gone. We should be implementing kind of standard gauges to the infrastructure and then implementing standard gauges to the vehicles. But there's always going to be that way up that where you're not using the full amount of the gauge. You want to get a little bit more capability by doing the absolute gauging. So yeah, I think it's a difficult one.
You're right. If I could take chair's prerogative for a moment, there's an example where a fleet has been taken advantage of the big hole that was on the Great Central route. So Chiltern's 165s are very wide, which is great from a passenger perspective. It's great from an operator's perspective. But where they run off that Great Central, the old Great Central route, such as Oxford Parkway and into Oxford Station, that's now creating problems for the other vehicles which run on those routes. Mm-hmm. And if we're trying to get towards level boarding, that's creating quite a difficult problem to actually put the platform in the place that fits the step for the 165, but also fits the step for any other vehicles that happen to want to use that platform. It's a problem I'm wrestling with myself right now, and I don't know what the answer is.
No, I'm not sure. We did look at we looked a few years ago at changing some of the standards because we were just going through a phase of making the gap between the platform and the trains much bigger because we were just focused on the actual gauge clearance. But I think it has kind of turned around now, and we are focusing more on the passenger interface and finding ways to bring the vehicles closer to the track. But again, it's having more accurate data and better understanding the behaviours of the vehicle and the infrastructure.
Mm-hmm. Okay, Mick James, you've got your hand up. Do you want to switch your camera on? Well done, Mick.
Yeah. Thank you, Karis. Very, very educational. I'm looking at it particularly from a vehicle point of view, so I admit a bias right from the start. But gauging engineers have been saying for some time now that the current processes are potentially too pessimistic. I'm not stupid enough to believe that we can go back to the old sectional appendix saying a route was clear to W6A and we could put vehicles down it and that was the end of it. So I understand that we've moved on from that. But there are so many examples where the pessimism has made life more difficult for everybody. And vehicles are of the same size as historically been allowed somewhere are all of a sudden banned. I give the example of a 165. It's funny that Louise just mentioned 165. But 165s, it was discovered 25 years after the event that 165 actually had a 10mm negative clearance at Goring Station. Well, 165s were going through Goring Station scores, if not hundreds of times a day for 25 years. And as far as I'm aware, there was never a collision. So I guess what I'm trying to say is there any reassurance that you can give me in your role as a gauging engineer, that actually things are going to improve and this pessimism that has pervaded the industry in the last 20 years, are we going to see, is there light in the end of the tunnel?
Yeah, I think there is. I think I can start off by saying that the track and structures do move around. So although it might have been clear when the vehicle was first introduced, something could have happened to make that change. And it's not always that somebody physically goes and moves the track. It moves itself. I mean, up to 25mm per year. So if that's what's been happening and the track has been migrating towards a platform, like I said, the standards in place that should be picking that up and then moving that back into the gauge cleared position. But at the minute, like it's too big of a problem to implement. And I have been working with Network Rail. Like this was kind of prior to taking this role in terms of writing the new standards to monitor and maintain tight clearance infrastructure. So I think there's lots of things at the minute falling into place to implement that standard. So hopefully in the next kind of few years, you will see that there is this new kind of risk-based approach taken to gauge clearing infrastructure, and that stuff starts to get actioned. So if the platform was tight because it's moved, it should be moved back. And if there's somebody's looked at it and said it's not moved enough to be a risk, then it's fine for the vehicle to operate. But yeah, it's just at the minute we're kind of in that limbo stage of trying to use engineering judgment, but ultimately to make the decision on whether vehicles can operate or not, because we don't have all of the information that we need.
Does that address your point well enough, Mick?
Like it's one step towards. I'd still like to see the light at the end of the tunnel rather than the headlight of the train approaching me.
A bit of a politician's answer, I guess, wasn't it? But no, I do think I can see change, and I think that, like I said, to me, it's having the data and understanding what's going on. And at the minute, we don't have that sight, so it's hard to say whether something's safe or not without changing things up.
I think having a point of reference from which to start is a good place from which to be. And if those standards are going to be in place, that's the place from which to start. So let's hope that's a good step along the way. Nigel, do you want to come on screen and ask your question?
Oh yeah, can you hear me?
Yes, we can.
Right. It's a question from a son of a civil engineer, P-way engineer. How do Network Rail these days pass this gauging information on to their track maintenance machine operators to make sure they aren't causing trouble with gauge when they're doing the maintenance? I recall a story of my father talking to an old boss of his that became one of your senior engineers, and said that when Rail Track were buying all these new fancy machines that were doing everything that people used to do, they forgot about the 6 foot and were allowing the machines to decide what they were going to do without reference to the track next to it. I'm assuming that's all under control now, but it's a similar thing. Is how do Network Rail now make up for all that lack of local knowledge that used to be there when, you know, every bit of railway line had an engine, you know, a technician that looked after it, and he knew his patch. He knew where all his tight structures were. He knew where all his tight 6 foots were. You know, I can think on the Portsmouth Main, I can't think of the number, one of the tunnels up there, where it was quite often that door handles used to touch in that tunnel on Mark 1 stock.
Wow.
So, you know, what is the arrangements these days? I'm just interested.
Okay, so they do have kind of specialist people that go out with the on-track machines, and they'll do a pre-site, a pre kind of shift survey to make sure that they flag up any concerns. So they'll measure the 6 foot, they'll consider whether there's any structures through there, and then in advance of the work taking place, they should have some kind of thought to the design that they're going to apply that night. So I know a lot of the machines, they just kind of apply their own design, but they will have picked up on the tight 6 foot. So I think they do like a measurement every 10 meters or so it is to make sure. So we do have a standard 6 foot that we know is safe for all kind of passenger stock, all vehicles even. So we know that once it goes below that standard 6 foot, we then have to measure. So there should be a clearance assessment in advance to understand how close those tracks can get to each other before there's an infringement. And the same with the structures. If there's a structure through there, Network Rail do have a tight clearance structure database. So again, the people going out and carrying out the work should be downloading any structures that were within their working mileage and understand if there's already a problem, and if there is, they should be doing a design to that. And all of these designs where they're making anything kind of substandard to like the normal, they have to have approval from the Network Rail gauging engineers. As far as I know anyway, that's the process.
It sounds like they've tightened up on the process.
Yeah, like I say, I think with every on-track machine, they do have, I'm trying to think of the name of the role now, but they do have some kind of experts that are out with the machines and checking the track quality and the kind of the final position of the track before it's handed back, and make sure it's safe to be open the next day.
Thank you.
Karis, I've got a question that builds on the question I think that Mick actually asked just now. So if let's say we take an initial gauge run and we don't do absolute gauging, and we think we come up with a clearance of, I don't know, some number, let's say 152 millimeters, and then we choose to go to absolute gauging, have you got some sort of feeling about how much you typically might gain by way of shape and size when you do go from sort of the simplistic to the absolute gauging? Is that possible to say, well, maybe it's typically in this range, or is it just variable according to different factors of vehicle or location?
It's definitely variable. I think it depends. So when you, especially with the kind of the freight loading gauges, I think it can be anything that's sat within that gauge. So it could be an untracked machine, so a tamper. It could be like a container traffic. It can be a load of cars. I've seen kind of cars transported on the backs of trains before. So we have to just look at it on an individual vehicle basis, I think. And there tends to be, especially nowadays when we're introducing new vehicles, we do a compatibility assessment with each vehicle to confirm that it sits within a gauge, and then build an absolute gauge model of any extra space that's available. So yeah, it's quite difficult, I think, to say.
Okay. Well, I suppose as a lazy vehicle engineer, I was just hopeful there was a nice answer. Say 2 inches.
It depends.
Imperial.
Yeah, we'd have to. I think the biggest kind of factor would be the vehicle suspension. I think the bouncier the suspension is, an old buggy, you probably might save some room, but yeah, I'm not sure. We'd have to have a look at all of the details to understand on a vehicle basis.
Fair enough. Right. Do we have any further questions? I'll take that as a no.
There is one in the chat box, Louise.
What does it say? Always a TQS out with a tamper.
That's what I was saying, that there's somebody that goes out with the on-track machine. Track quality supervisor is the role. Thanks, Nick.
Thank you. Yeah. Thank you very much, Nick, for that help. Any more? Otherwise, I will ask Andy Batters to do the vote of thanks for Karis, please.
Okay. So thank you, Karis, again. I've had the pleasure of working with Karis and colleagues from Omnicom for the last 18 months on a project, and I can tell tell everybody firsthand that she's passionate about her role and and the effect on the infrastructure, the effect on the industry as a whole. So no, I think it's been a fantastic evening. We've learned a little bit of history of gauging and some of the exciting tools that Karis and Omnicom have got in their armory. And the reverse engineering one has been particularly helpful. Going back and having sort of a process of iteration of, can we put a little bit more on here, or in my technical speak, there's too many sticky out bits, so we need to reduce the number of sticky out bits. And Karis has obviously worked on some very exciting projects a little bit earlier in her career with Hitachi and IP, which does show that train manufacturers and the infrastructure can work collaboratively. She's explained some new technologies and point cloud surveys. I've only got one really serious message, and then one of a bit of a joke message is anybody that's doing this stuff, just have some early engagements with a gauging engineer, and that's paid dividends for my project. And then if all else fails, you've got one last option, which is to get the angle grinder out or start chopping bits off your vehicle. So if I could ask you to all unmute your microphones, and if we could thank Karis in the usual way.
Yeah, well done.
Thanks, everyone.
And thank you, Karis.
Sorry about the technical difficulties. Like I say, I was planning on having my camera on, and I've kind of, in hindsight, I've probably skipped over some information with nerves as well. So if anybody wants another chat about anything I've discussed tonight, then again, I'm happy for those slides to go out. I don't know if it's common practice to share the slides, but yeah, if you want to share them, my contact details are on there. So get in touch, and I'm always happy to kind of chat to people about gauging and the like. So yeah, thanks for having me.
Thank you very much, Karis. I'll just put my slides back up for a moment, just so people can see the parish notices and the addresses once more, and then a little bit of an advert for our next lecture. So bear with me a moment, everybody. Right, there we go. So if you want to take a quick note of those details to find out about upcoming events, we have the Northeastern Near You page, which is just our events. We've got the Railway Division web page, or the Railway Division's events page. That's the simplest one to work out, imeche.org/events, and then you can filter for railway events from there. We have a LinkedIn group for the Northeastern Centre, so just go to LinkedIn and search for IMechE Railway Division, and you'll find all of the centres, I think, have a LinkedIn page there. And if you wish to join the mailing list, which sends out the posters and the publicity for all of these events, email me at rdnechair@imechenearyou.org. So I'll leave that up for a moment or two longer if anybody wants to write that down. We do keep that updated with any changes, whatever that might be, by way of time or venue or change of speaker, that sort of thing, which frankly, thankfully, doesn't happen terribly often. Okay, if you do, you can search using the usual search engines for Near You, Northeastern Railway, IMechE, and you'll find us. So our next event is the chairman's address, a gentleman called James Collinson, Dots and Boxes, What Can It Teach Railway Engineers and Organisations, on the 19th of October. We have some details to work our way through in order to be able to give you the final information about that. We're hoping that it will be a real face-to-face event, but we have some logistical issues to work through yet. So keep an eye on Near You. And if needs be, we will run it virtually or perhaps as a hybrid, depending upon how circumstances work out. So do keep your eyes focused on Near You, and we'll update you as soon as we can. Otherwise, I'll leave it to say thank you very much from me to Karis, under somewhat testing circumstances when you're somewhat worried about your internet connectivity. Doing one of these things can be hair-raising. So well done, Karis. And thank you to everybody who's asked a question. Karis has kindly offered to field any more questions if you'd like to. So I'm going to